This is something I've been contemplating lately.
Okay.
Knowing whether or not you know or understand something is a skill that one should develop, or one can develop, right?
Sure.
An example comes to mind is, you might say, like, why is there no moon around Mercury or something like that? And then so you type in the search engine and the Google AI answers you, and it says something about the solar winds of the sun stripped away the hydrogen in the atmosphere of Mercury. So you could read that and say, oh, now I know why there's no moon formation, right? No moon formed around Mercury. The reason is the solar wind stripped away the hydrogen formation in the atmosphere. But like, I feel like, no, you don't know why, because what does the hydrogen in the atmosphere have anything to do with moon formation, right? Unless you can answer that, then no, you don't know why there's no moon that formed around Mercury. And it's not obvious, I guess. Like, that realization is obvious. You have to, like, I don't know what you have to do. Do you have to think about it, or like it has to be like some sort of inspirational spark, or it's a habit that you train in yourself? Like, how do you, if someone were not to realize that they didn't actually understand moon formation, how could they start to realize that? Like, you know, what training could they do to develop a relevant skill?
It's sometimes called the illusion of competence, right? You think you know how things work. The original studies were done with things like ballpoint pens, zippers, toilets.
Yeah.
They asked people like, hey, do you know how these things work? And everybody was like, hell yeah, I know how those things work. I use a pen successfully every day. And so then what they did to test this, because they were like, how are we going to test if people actually really do know these things? They tried to get them to describe it, but people weren't very good at describing it, whether they knew it or not. So the solution they came up with is they had them draw how these things work.
Yeah. I remember,
even if they're sort of,
how does a bicycle work? And they draw a bicycle. And like, it doesn't make any sense what they drew. Like, there's no way it would work. Because, like, for example,
oh god,
like the pedal has, like, you know, there's a gear and there's a tire, but then they're not connected.
Right.
So how would pedaling cause the wheel to turn? Like, it doesn't make, you know.
Yep. And then you try to draw the chain, and you're like, oh dang, I don't even know what does it go to the handlebars? I'm not.
Yeah.
And they found that it works really well even for verbalized concepts. So I think a way that you could start doing it is to say, like, okay, could I draw a situation in which Mercury did have a moon? Could I draw a situation in which the Earth, like, something happened to the Earth and it didn't anymore? Could I, like, when they say hydrogen, could I draw what that is, right? So I think that's one way that you could do it, because drawing sort of forces concreteness. It forces precision that verbalizing concepts doesn't necessarily. So that might be one possibility. Feynman was also famous for suggesting people draw things out.
That's interesting. Because I feel like I vaguely understand moon formation. And I don't see how I would draw that moon formation. Like,
well, how would you explain moon formation?
When the solar system, like in the early days, it was like just a bunch of random particles, like a cloud of gas type of thing, dust particle floating around the sun. I don't even know if the sun is formed yet or not at this point, but I'm gonna assume for now that the sun is formed. And so the particles are swirling around the sun in like a disc, like a dinner plate, like a flat disc like that.
Okay.
And then like clumps of it start to form in those discs, and those become the bodies, like, which I'm using a more generic term, bodies, because like some of them then become planets and some of them become moons, and the ones that become moons are the ones that are close to something like a bigger brother, like a bigger thing, right? And so it gets captured by that bigger thing and then becomes a moon of that.
Yeah, and I think that's all drawable, don't you think?
I feel like it would have to be an animation in a sense, right? Like,
sure. You're thinking as you're drawing, or, you know, kind of imagining what the animation would look like.
Yeah.
You're sort of like, well, what makes it so that the things start to clump, right? And then you start independently developing peak selection theory math, right?
I don't know what that means, but sure. Let's say I do that. Let's say I start developing peak selection theory math.
Where basically what you realize is that why would those things start clumping, right? What's happening that they're clumping together? Why would they clump rather than just bang off of each other? If you start thinking, well, they're colliding, why are they sticking together rather than just sort of billiard balling around? What's happening there? And then you start thinking about gravity, you start thinking about gradients, you start thinking about, right? And then you start realizing how much you don't know, and then you kind of add to your knowledge that way. But I think that's a good way to start checking your own knowledge is draw it. The other thing people sometimes recommend is that you try to teach it to a 5-year-old, right?
Yeah, but I'm worried that you need to first develop that I don't understand it detection, or I mean, this is how you develop it, right? So what's tricky about it, yep, I feel like, is if you fool yourself in the way the Feynman was talking about, into saying, yep, oh, I understand it. It's that the solar winds wiped away the hydrogen or whatever, right?
Right.
And then what's to stop you from saying, well, I would just tell the 5-year-old that the solar winds wiped away the hydrogen, and there, I've explained it to the 5-year-old,
Right, and the best thing to do in that case is to actually get a 5-year-old, because they will quickly show you, right? And this is why you're supposed to try and teach these things. And by teach, meaning not just write a Substack, but like actually try to explain it to another person.
Are you calling me out here? What the heck? It's not enough to just write the Substack.
You actually get someone who says, but wait, what the hell is solar wind, right? And then you're like, or maybe you do know. But you actually have somebody there questioning and saying, like, I don't get it. I don't get it. Like, if they had run the tutorial of this game by me, like, I hope it would be a lot different, because I would have just been like, what the literal...
Yeah.
What are you talking about, right? And unfortunately, they didn't. And so this game suffers from the curse of knowledge, where they're like, oh, we explained it great. And I'm just like, I mean, even you were like, I don't know what the goal is.
Yeah, well, now, like, it took a while to figure out... because there's like, there's only one place where the blue dot is at the bottom. So I said, oh, I guess that's where I need to make the blue dot go. But yeah, they should have said that at some point, right? They should have said, look at the bottom. You see where the blue dot is? You want the blue dot to go there.
Go there.
Yeah.
Just play around until you get to that. And then later we'll explain to you what you're doing.
Right. And like this thing, I feel like, I'm just brute forcing, because I don't understand... When I place a gate here, I don't understand how to predict which wire is going to go where. So I was like, okay, I'll put the wire here. Did this work? No. Okay, I put the wire over there. Did that work?
And supposedly, I think they said in the tutorial, the people who are good at it aren't guessing. They're also not doing math.
Yeah, they said it's not doing math. I'm like, what does that mean? Like,
yeah. Okay.
Because I remember there was also 8-Bit Dater, like a while ago. He asked me, like, how would you solve this problem? I forget what it was. It was something like you have 3 consecutive numbers, and then like if you take the average of the bottom, like they add up to 23, and you take the bottom 2 numbers or whatever, and then blah blah, right? And then I'm like, okay, yeah, so the answer is 14 or something like that. And he was like, wow, you solved it without doing math, right? And but no, I did do math. I did it in my head, right? I'm just like, maybe because I wasn't like mumbling numbers out loud, that there was the illusion that I wasn't doing math, but I was definitely doing math to solve that. Like I was trying to say, well, I know that there's consecutive numbers. So in my mind, I'm like, instead of saying there's 3 unknowns, I'm saying there's 1 unknown, which is x, and then x plus 1 and x plus 2, right? Those are the 3 consecutive numbers. And I'm solving for x or whatever.
And this game literally said, if you get good at it, you'll develop an intuition for linear algebra,
which is math.
Like, I don't know if you know, but linear algebra is math.
No, like I got it. If I just try every combination, eventually.
What fun! I often realize that I don't know something as well as I thought I did when somebody else tries to explain their idea, which I know is wrong, but I'm trying to explain to them why I'm wrong, and then I'm like, God damn it! I don't understand this idea well enough.
Yeah.
I know that they're wrong, but I don't know it well enough to explain to them why they're wrong.
Right.
Unfortunately, I find out limits of my knowledge that way a lot.
The thing also, going back earlier to what you were saying, I guess you were teasing me. I don't know if it's intentional or what, but about like it's not enough to test that you understand the subject by just writing a Substack.
It was not. You made it personal. I was not.
I'm taking it personally.
Using you in any way.
I write Substacks.
It's not about you.
That you then read.
You have started a Substack. I had forgotten.
And then you're like, and then you disagree with everything I say. So that's why you personally attack me by saying, just because you write a Substack doesn't mean you know what you're talking about.
None of this happened.
But here's so you said like, you know, instead of writing like, it's not enough to just write a Substack. You need to like actually like present your arguments to someone and see if they understand it, right, or something like that. Like I think that's more or less what your point that you were making.
I was making the point that like often it helps to have a literal person there who is questioning, because you can write like obviously you can figure out pretty quickly on a Substack if you don't know at all what you're talking about. But that specific state that you asked about where you did well enough to write it and you're like, well, I was able to write an article about it and I wrote it to an imaginary 5-year-old, so maybe I do know it. And I was saying like in that situation, I think you actually need someone there questioning you so that you don't fool yourself into thinking that.
Yeah.
But mostly I was just making fun of your specific Substack.
Yeah, I got that.
Which I was in no way doing, but all right.
I've been writing some Substacks recently, and what I have been doing is I've been copy and pasting the contents of my Substack to LLMs, and I say like, act as a skeptical reader and tell me what do you find least convincing in my argument, what are the flaws, what have I forgotten to address, and so on.
What's it doing?
Well, it says stuff, but how do I know it's not being sycophantic?
Right. It does have a pretty high agreeability bias.
Because it says stuff like, you know, you've explained the topic of, I don't know if you saw my most recent Substack stuff, prediction, limitations of prediction and Turing machines and things like that.
I don't think so.
Okay. It was telling me like, you explained all of this very well. You know, there's just minor nitpicks and it lists them, and I'm like using my own human judgment. I'm like, I think it's like it's wrong about the like it's a judgment taste, right? Like it's an editorial thing where I'm saying like, you know, you think it would be better if I talked about how, you know, the philosophical foundations of constructivism in math or whatever, and I'm like, no, I don't think I should talk about that. I think it's completely off topic to what I'm talking about. So I, you know, I say I like to post the way it is. I'm going to post it as is. But as far, it didn't really give me stuff where it says, you know, like there is a flaw in your understanding, and here it is, right? And so I don't know, like, is it because there is no flaw in my understanding, or is it because it's being sycophantic?
I think you can ask it. I think you can say, like, prioritize accuracy over being nice to me. Like, don't worry about, you know, trying to sugarcoat it. Like, really tell me if there's a flaw in my argument that I don't understand.
Sure, but there's a false negative problem, right? Like if it does say, yeah, there is a problem, then I know there's a problem. But if it says, no, there's no problem, then I don't know if there's a problem or not. So,